Dear students, let us revise the concept of hybridization once again. The concept was introduced by Pauling. It is the process of intermixing of the orbitals of slightly different energies so as to redistribute their energies, resulting in the formation of new set of orbitals of equivalent energies and shape. The atomic orbitals combine to form new set of equivalent orbitals known as hybrid orbitals. Salient features of hybridization. The number of the hybrid orbitals is equal to the number of the atomic orbitals that get hybridized. The hybridized orbitals are always equivalent in energy and shape. The hybrid orbitals form stable bonds. The hybrid orbitals are directed in space in some preferred direction to have minimum repulsion. Important conditions for hybridization. The orbitals present in the valence shell of the atom are hybridized. The orbitals undergoing hybridization should have almost equal energy. Promotion of electrons is not essential condition prior to hybridization. Half-filled or fully filled orbitals can participate in hybridization. This is the summarized chart for the hybridization. Hybridization can involve the mixing of s, p and d orbitals, and according to that it can be sp, sp3, sp2, sp3d2 and sp3d hybridization. Dear students, we have discussed hybridization in ethane molecule. Now let's discuss hybridization in ethene. Ethene C2H4. In ethene, the hybridization is sp2. Just now we will see that how the hybridization is sp2. In ethene molecule, between the two carbon atoms, there is one sigma bond and there is one pi bond. Sigma bond is formed by the end-to-end overlapping and pi bond is formed by sideways overlapping. The two carbons are attached to 2 hydrogen each. Now in ethene, again you can see that the atomic number of the carbon is 6. Its electronic configuration is 1s2, 2s2, 2p2. In the ground state electronic configuration, carbon has only 2 unpaired electrons, but carbon shows covalency of 4. It is a tetravalent. Then how does it shows the tetravalency? Let's see. Promotion of electron. One electron from the 2s orbital jumps to vacant 2p orbital. Now you can see that 2s and 2p orbitals, they have 1 electron each. These are 4 unpaired electrons now present in the carbon, and this is how the compounds of the carbon are tetravalent. But before carbon combine with the other atom, these 4 orbitals will undergo intermixing, that is hybridization. In ethene, the sp2 hybridization is there. 1s and 2p type of orbital will intermix and 1p orbital will remain unhybridized. 2p orbital, they will hybridize to give 3 sp2 hybrid orbitals, which will orient themselves along trigonal planar shape with a bond angle of 120 degree. Let me show you through this. These are 3 sp2 hybrid orbitals with a bond angle 120 degrees. These sp2 hybrid orbitals have 1/3 of s character and 2/3 of p character. Just see the orientation of 3 sp2 hybrid orbitals. This is a 3-dimensional view of ethene molecule. You can see that there is a dark grey or blackish cloud of electron above the carbon atom plane. The 2 carbon atoms and the 4 hydrogens which are shown by the blue balls are in one plane, and you can see the pi bonds which are formed by side to side overlap. There is a double bond in ethene molecule. Now you can see from here the 2 black balls are the carbon atoms. Each carbon atom is bonded to 2 hydrogen atoms shown by the white ball. And this blue pipe or the blue overlap, you can see one above the plane and the other below this plane. This is pi bond. This is formed by the sideways overlapping. Now you can see this. This carbon and these 4 hydrogens are in one plane, and this pi bond is above and below the plane. This is ethene molecule. Here you can see the sideways overlapping and the end-to-end overlapping. The blue orbitals are sp2 hybrid orbitals. You can see that the sp2 hybrid orbital of one carbon is overlapping with the sp2 hybrid orbital of the other carbon, and result is the formation of a sigma bond. And then you can see also the 2 sp2 hybrid orbitals of each carbon is making bond with the 1s orbital of the hydrogen. The unhybridized p orbital is shown by the yellow lobes. These yellow lobes, they will undergo the sideways overlapping to form the pi bond. Just see the figure. The sideways overlapping, 2 lobes above the plane and 2 lobes below the plane making pi bond. This is the orientation of the sp2 hybrid orbitals in a trigonal planar manner. This is again a depiction of the ethene molecule, a 3-dimensional view. Here you can again very well see that the 2 carbons and the 4 hydrogens are in the one plane and the p orbital lobes above the plane and below the plane. This is the yellow electron cloud above and below the carbon and hydrogen atoms plane. Dear students, now by taking the example of ethene or ethylene, that is C2H4, the concept of hybridization must be clear to you. Again you have seen that how 1s and 2p orbitals of the carbon intermix to form 3 sp2 hybrid orbitals before carbon bonded with the other carbon and the hydrogen atoms. Thank you.